Hi everyone, welcome back to Geeks for Geeks practice. Today in this video we'll be solving the problem of the day for 28th of January. The name of the problem is nCr mod M and its part 1 is this, and this problem is a little bit for competitive programmers, I would say, but still we'll be learning how to solve this particular problem. So quickly consider giving me a +1 in the chat if my voice is audible and my screen is also visible, and then we'll start with this particular problem, right? So there are several ways to do this particular problem. I'll be dealing with one of them. So just consider giving me a +1 in the chat if my voice is audible and my screen is visible, and then I'll start within a couple of minutes once everyone else joins in, right? Okay, you can just consider giving a quick +1 in the chat for a little acknowledgement that everything is working fine and we will be good to go. Perfect. So 7 people have joined us. Hi Alok. Hi Sanjeev. Okay, so just a little bit of things like meanwhile everyone is joining, so just a little bit of information that I wanted to give you. So we have this channel powered by Geeks for Geeks, that is Code Era. So on this particular channel every day we are streaming for lead code daily challenges. Apart from this we are also doing Code Forces editorials, like we have a contest tomorrow and day after tomorrow on Code Forces, so we'll be streaming that as well. Apart from this we have a Code Force at Coder beginner contest today, so I'll be I'll be making editorials for that as well, so you can consider to check out this channel. Apart from this, like if you are someone who is new to CP, so you can consider to watch my playlists that are Mastering Code Forces Game Theory, Mastering Code Forces Sorting Series, things like that would work. So you can check out this channel. You can just search Code Era and it would help, right? So yeah, tough time to handle. Alok Ranjan Srivastav, we'll see that. Okay, hi Lalit, hi everyone else. So you can consider to subscribe the channel if you don't know about it. Now coming back to this particular problem, so everything is working fine, right? So you can, all of you can just give us a like. Okay, perfect. So let me tell you what this problem actually says, right? You must have heard about this concept, that is nCr, right? That is the number of combinations. So nCr is what? You'll be given an integer n and you'll be given an integer r. So how do you actually calculate an nCr, right? Let's come to that point. Like how do we actually calculate an nCr? Anyone knows what is an nCr or how do we actually calculate it, right? If you have an nCr, right, so this means for the combination, so we'll not be talking like what is nCr and PR in this particular video. I'll be just directly telling you like what we have to do in this particular question. So if we have, bhaiya, can you again repeat about the Code Forces contest you said? When is the contest? You can check out on the Code Forces website, like they must have provided the dates. I think one contest is tomorrow and another is day after tomorrow, so you can consider to give that contest. And on our channel Code Era we will be providing the video editorials, like me, Hitesh and Ayush Gupta, all of 3 of us would be making the video editorials for the future contest. So you can consider to subscribe that channel. You can just search on YouTube Code Era, code space error, and it would come, right? So now coming back to this particular problem, like if you have an nCr, right? So what is an nCr? nCr is nothing but n factorial divided by r factorial into n minus r factorial, right? So how many of you know this, right? And what is n factorial? What is n factorial? N is n factorial, let's say we have 4, so 4 factorial is what? 1 into 2 into 3 into 4, right? Is this much part clear to everyone, right? I hope that this factorial part is clear to everyone. Now similarly, if you have to find the factorial, so this would be n factorial upon r factorial into n minus r factorial. So you will say that okay, it's very easy to find, right? If I give you some numbers, let's say I give you n is equal to 10, r is equal to 4, so if I have to find 10c4, right? So that's pretty much easy. That seems easy. Why? Because that would be nothing but 10 factorial divided by 4 factorial into 6 factorial, right? Please give me a +1 in the chat if you agree with this part, right? A +1 in the chat, an acknowledgement in the chat would help, right? So these are the things that you can have. But when does the problem arise, right? When does the problem arise? Now you just look at the constraints. First of all, let me go to this question and just look at the constraints. So if you have n and r as 10 to the power 16, right? If you are having n and r as something but 10 to the power 16, right? If it is 10 to the power 16, so let me tell you a little bit of problem. Just give me a second. Okay, right? So what I'm saying is, if you have nCr and PR, things like that, so that's perfect, right? But if you just calculate what is something like a 6 factorial, so 6 factorial is nothing but 5 factorial into 6, right? So that would come out to be how much? 5 factorial is how much? 4 factorial into 5, right? So this is how much? 24. This is 120. Now this becomes 720, right? So if a number like 6 factorials becomes 720, then 7 factorial and things like that, the number becomes very large, right? So the number becomes out of bound. The factorial that you calculate becomes out of bound, right? Out of bound, what do I mean by that? So it becomes it goes outside the capacity of even a long int, things like that, right? So highest capacity that an integer can hold, it goes outside of that. So how do you encounter that particular situation? That's the thing, right? What I'm saying, like, you might not be clear. So what the question says is that if you have a number n, right? If you have a number n, so you mod it with m, right? You mod it with m. What is m? M is a very large prime number, right? Very large prime number, right? M is a very large prime number. They would be giving you, like, usually it's 1e9 plus 7 or 1e9 plus 3, whatever it is given. So it is very large number, right? So how does this help? So if you will actually observe, so this will help because m is a very large prime number. So since m is a very large prime number, so that's why you will be able to control this, right? If you go out, this modulus application, this modulus applying mod m would help to keep the n within the limits, right? To keep the value within the limits, to help it not cross the higher bound. Otherwise the number would become negative or it would overflow, right? So to encounter this particular situation, this is why you use it, right? Now the thing is, like, how, like, does that affect? So if you have 720 and you mod it with whatever has been given, like 10 to the power 9 plus 7, that is a very big prime number, in that case it remains 720, right? But for the larger numbers, it would help, right? So this is the application of applying a modulo. Now the thing is that you must be knowing, like, you have to apply a modulo. So you'll say, perfect, like, you have to just apply a modulo, like whatever value you'll be calculating, like n factorial upon r factorial into n minus r factorial, right? Something like this. You will say that, okay, let's apply modulo directly, but this is not the thing, right? This is not the way. I'll be telling you, like, why. Okay, so this much part must be clear to everybody. Like, m is a very large prime number. That's the speciality about it. M is usually a very large prime number, right? If you keep m is equal to 2 in or things like that, then in that case you will not get the proper answer, right? So that is why we keep m as a very large prime number usually. Okay, usually 10 to the power 9 plus 7 or anything that that the question requires, that will be given to you, right? So if you have a mod m, so you will say that, okay, it's perfect. If you have an expression a plus b and you have to do mod m, so you will say that, okay, this would become nothing but a mod m plus b mod m, right? Like this. If you have an expression like a minus b mod m, then in that case you will say that, okay, this is nothing but a mod m minus b mod m, right? Something like this you will say. If you have a multiplied by b modulo b, so you'll say that it's nothing but a mod b into b mod a mod m into b mod m, right? Something like this. Is it mandatory for the from interview standpoint? I mean, I read about Lucas theorem. I felt it won't be very useful. Yeah, not usually asked in interviews. Not usually asked in interviews. This particular problem is not usually asked in interviews, right? Like, they would just ask you, like, how to find it. That would be much more than that. Otherwise they would not ask you very much, John, right? So now the thing is that this is perfect, this is perfect. But if you do a divided by b, right? If you have something like this, that is a by b modulo m, then in that case you cannot write it like that, like the way we do. What you have to do in this particular thing is, otherwise you'll get a wrong answer, right? So what you will do is, you'll have, if you have to do mod with this, so you'll write a b, right? A into b to the power minus 1, right? You will write b in this particular way, right? What I'm saying, let me conclude a little bit more. So this is not very much important according to an interview standpoint. Like, if you are going for companies like Code Nation or Sprinkler, so they might ask you things like this, but usually I haven't seen other companies asking this, right? I can see a lot of people have joined us, so you can consider giving a +1 in the chat, and you can like the video as well. Okay, you can give a +1 in the chat for the acknowledgement purpose, and that would help us, right? So if you have a by b, what I'm saying is, if you are doing it, right, if you have a by b and you are doing mod m, So how you do it? You will not do it like directly. You will do a into b to the power minus 1 and modulo it with m, right? Like you like it, write it like this. After this, what will happen? After this would become a mod m into b to the power minus 1 modulo m. Okay, please write clear in the chat if this part is clear, right? This is the part, this is the part. Now the thing is that how do you calculate such an expression, right? How do you calculate such an expression? This is simple a mod m, but this is inverse, right? This is an inverse part, so what I want to tell you is that what I said, let's repeat it. Let's repeat it again for the clarity purpose. Let's repeat it. I said if you have a divided by b modulo m, so you write it as a into b to the power minus 1 modulo m, and then what you do? You do a mod m plus like into b to the power minus 1 modulo m. Right, now the thing is that you will be able to calculate this particular expression, but what about this expression, right? So that is what I'm going to tell you. Like if you have b to the power minus 1, right, and you are doing it modulo m, right? If you are doing it modulo m, does anyone know what we have to write for this particular situation? How do we calculate it? Like this is the situation, then in that case it would be nothing but b to the power mod minus 2. Is this part clear to everyone? Like if you have this is a formula. If we'll go into the explanation, or if we'll go into the depth of its solving, then in that case it would give us a little bit of like it would take a lot of time and it would not be convenient for us. But this part must be clear, right? If there is something like b to the power minus 1 mod m, right, where m is mod, like this is mod, so it would become b to the power mod minus 2. It is same, right? Is this part clear to everybody? Like if you have an expression, what I'm saying, if you have an expression like this and you say you are doing its mod with a mod, like a particular number, then in that case this is nothing but b to the power minus 1 modulo m modulo mod, and this is nothing but similar as b to the power. Now this cannot be calculated directly, so you will represent it as b to the power mod minus 2. If you calculate this particular value, then in that case it's equivalent to this value, right? Consider giving me a +1 in the chat and like the video if this much part is clear to everyone, right? Is this much part clear to everyone? Please give me a +1 in the chat. A quick +1 in the chat would help, right? Okay, everyone is clear with it. What about Shreya? What about Alok? Everyone is clear with this? I hope that everyone is clear with this part, right? If you have 1 by b mod m, so you write it as b to the power minus 1 mod m, and that can be represented as b to the power mod minus 2. So if you calculate this value, then that is nothing but the modulo inverse, right? This part you won't be able to calculate directly because you don't know. So this part is what? b to the power minus 1 mod m. So its equivalent value is this, right? If you calculate b to the power mod minus 2, then in that case you will be able to get this part, right? You will be able to get the exact same value, right? So this is the thing. This is the thing. Now let's come back to this particular question of ours, right? Let's come back to this particular question. Now in this particular question, what they are asking you is like they have been asking you nCr, right? So what is nCr? nCr is nothing but, I would say, n factorial upon r factorial. Correct me if I'm wrong. Correct me if I'm wrong. Okay. This is the thing. Now they are saying that you completely like take a mod of this value, right? They are saying that you completely take a mod of this value. But can we do this directly? Can you relate this with this a by b mod m, right? Can you relate these two things? Can you relate these two things? If you can relate, please write yes in the chat, and then I will proceed further with this question, right? Can you relate with these two things? I hope that you can relate with it, right? I can see a lot of people are watching us. You can give me you can write yes in the chat if you can relate with it, right? Hi Aman. Okay. Can you relate with this, right? This expression with this expression. I hope that you can relate it, right? So that's the thing that I was talking about. So let's try and keep it like that. Let's try and keep it like that. So everyone is saying yes. Perfect. Sanjeev is also saying yes, right? So what I'm saying is, this is the expression that you have. So if you will try and see, so how do you calculate this particular expression, right? So let's say you have n factorial. You denote some of the things, right, for easier purpose. N factorial is equal to, let's say, x, or let's say a. Okay, n factorial is equal to, let's say, a. R factorial is equal to, let's say, some value which is let's say x, x, or you can say p. P would be better. Let's take p, right? Let's take p. Now if you have n minus r factorial, let's say that it has some value, some integer value, that is q, right? If you like it, write it this way. So this would become nothing but a divided by p into q, right? Like this, and then modulo m, like this. Okay, so if I calculate it further, so if I say that p into q is nothing but b, an expression b that I would be making, so in that case it would become a by b and modulo m, like this. Now are we closer to the conclusion? Yes, we are closer to the conclusion. This is nothing but what? A mod m into b to the power minus 1 mod, right? B to the power minus 1 mod m, right? Okay, this is the expression that we have. So this expression would remain the same, and I know that b to the power minus 1 modulo with m would give me b. It is the same as b to the power m minus 2, right? How many of you are clear with this part, right? Now let me write it once again for the clarity purpose, right? If I have a to the power b, I have reduced a lot of expressions, right? So like a is what? A is nothing but n factorial, and b is what? B is pq. Like p is what? P is nothing but r factorial, and q here is nothing but n minus r factorial, right? So I've just tried to reduce the a lot of expressions so that we can understand it better, right? This would be a mod m, and you simply multiply it with what? You multiply it with b to the power minus 1 mod m, right? And as I told you that this particular part would be nothing but it would be same as b to the power m minus 2. Please write clear in the chat. Please write clear in the chat if this much part is clear to everyone, right? Is this much part clear to everyone? Just let me know in the chat, and also like the video if you are understanding up till now. So you can please like the video. I'm trying to put in a lot of effort, right? So this much part is clear, right? So it would be nothing but a mod m into b to the power m minus 2, right? Something like this. Okay, this is the expression that we have deduced it to, right? Now the thing is that you'll say that if I have an expression like b to the power minus m mod m, right? If I have an expression like this, so if I do b to the power m minus 2, so you'll say that you simply calculate this value, right? But I'll say that if you calculate it directly, then it would take a lot of time. What I'm saying like this is there is a mathematical proof for it. So you can go on the GeeksforGeeks website, or you can go on the website CP algorithms, right? And you can read about the proof of this particular formula, Akash. Okay, like if I'll explain it, so it would take a lot of time because I still have to explain the code and other things for this question, right? So because now this is one thing, right? Now here comes the fast exponentiation concept as well, right? Modular exponentiation, or you can say fast exponentiation, right? What does fast exponentiation mean? So if I have a to the power 4, so either I can do a into a into a into a, things like this, right? Or I could do something else. If I have a to the power 4, so I can say it is nothing but a to the power 2 into a to the power 2. So if I have a to the power 2, so in that case I can simply know the value of a to the power 2, other a to the power 2 as well, and I'll be saved from calculating the other parts, right? Like if I had a to the power 8, right? And then I'll have a to the power 4, a to the power 4. So if I know this particular value, then this particular value I'll not be calculating it separately. Like I can directly put it, right? Like this. So I hope that this part is clear, right? Fast exponentiation or modular exponentiation, I hope you are aware with this. Like if I have to calculate 2 to the power 20, so I'll not do 2 20 times. I'll not multiply 2 20 times. That is not something that I'll do. I'll basically apply the concept of fast exponentiation to calculate it as fast as possible, right? I hope that if you are not knowing, so you can just go to GeeksforGeeks and you can learn about the concept that is fast exponentiation, and that would help, right? If you calculate this like linearly, so it would get m minus 2, like it would run m minus 2 times. But if you will calculate it efficiently, then I guess it would learn in log time. Okay, so complexity would reduce a lot. So that's how you are calculating this particular thing. Like as I said, if I have a to the power 5, so this would be nothing but a to the power 2, a to the power 2, a to the power 1. If I have this as calculated, so I'll directly put this value here, and a to the power 1 I'll be multiplying directly. Okay, so this is something that I'll be doing. Now the thing is that you also might have to do some pre-computations for this particular function, right? So if up till now things are clear to all of you, can we move to the code part? Can we move to the code part if up till now things are clear to all of you, right? We did this. So that I'm indicating that, let's say this is A, let's say this is A, so this would be A. Let's say the denominator expression, complete denominator is B, so this would be looking like this. Now this is what? A mod M into B to the power minus 1 mod M, so this would be nothing but B to the power M minus 2. This is A mod M. So this is how you can calculate the final answer, right? +1. Give me a +1 in the chat if this much part is clear, right? So like this is the part. Now let's move to the code part. Let me show, first of all, let me show that my code is working. Okay, let me show you that my code and approach is working. So it's passing for all the 90 test cases I can see. Okay, now let's see what happens next. Let's see what happens next. So in this particular function, like if I have this function like nCr, you can take a screenshot of it if you want. Like what I'll be doing is, first of all, I'll be passing a pre-calculate function, right? I'll be calculating all the factorials beforehand, like, right? Why? Because what I also want to tell you is, right, if I have very large numbers, if I have to calculate factorials, right? If I have to calculate factorials, right? If I have to calculate factorials, if I have calculated 4 factorial, right? And if I have to calculate, like if I have to calculate, let's say what? Let's say if I have to calculate n. So n is what? 1 into 2 into 3 into up till what? N minus 1 into n, right? And this particular part would be already calculated. It is also known as n minus 1 factorial, right? So what I'm saying is, if I have to find factorial of n, right, factorial of n is nothing but factorial of n minus 1 into n. So this is the thing that I'll be using. So I'll be pre-computing this, right? If I have a lot of test cases, then computing this again and again is very inefficient, right? Just compute it once and store everything. Store all the factorials, right? Store the factorial values. Store the factorials. Because if you'll store the factorials, that would be helpful to you only, right? Calculating, like if you know what is let's say if you know what is 6 factorial, and then you calculate 7 factorial like this, 1 2 3 1 into 2 1 into 2 into 3 into 4 and into 7, like this is a lot of time taking. This is not you can say this is not something which is very time efficient, right? If you want to calculate 7 factorial, so just calculate 7 factorial as nothing but 6 factorial, which is already calculated, into 7, like this, right? So this is what we will be doing with the help of pre-computation, right? So I'll be computing all the factorials before I'll be running for the function, right? So I'll be calculating this is the factorial, like this is the factorial array that I would be making, and this is the inverse factorial. I'll be calculating the inverse factorial, right? As I told you, inverse factorial is what? B to the power m minus 2, things like that. So initially I'll be marking factorial of 0 is 1, factorial of 1 is also 1, and inverse factorial of every number is what? Inverse factorial of 0 and inverse factorial of 1 is nothing but exponentiation or 1 to the power mod minus 2. Please write clear in the chat. If this 1 to the power is the factorial of 0 and the factorial of 1 is 1, so the inverse factorial, as I told you, inverse factorial, right? That is b to the power minus 1 mod m. That is the inverse factorial. So inverse factorial for numbers like 0 and 1, if the direct factorial is 1, so inverse factorial would be nothing but exponentiation of 1, that is 1 to the power mod minus 2. Please write a +1 in the chat if this part is also clear, right? Is this part also clear? A quick +1 in the chat and a like to the video would help, right? Please write a clear in the chat or a +1 in the chat. Okay, this is what we are doing. Now I am calculating the factorials, right? In this particular function, like I'll be calculating the factorials. So I'll be running from 2 and until less equal to mod, right? I calculate factorial of I is equal to I, that is the current number, that factorial of n is equal to n into factorial of n minus 1. This is what I am doing, and every time I had to take the mod, so I'll take the mod as well, right? I'll take the mod as well. Let me just put in some brackets, maybe that would be much more clear for all of you, right? So I'm doing something like this, right? Let me write it this way. Okay, this is something that I am doing, right? Now I also, if I calculate the factorial of I is equal to I mod, like factorial of n factorial is equal to what? N factorial is equal to n into n minus 1 factorial, right? And taking the mod. And what is the inverse factorial for that particular function? I'll also calculate the inverse factorial beforehand, so that I do not take much time. I only have to put the values whatever has been asked. So if I have inverse factorial of I, it is nothing but factorial of I, right? It is nothing but factorial of I mod minus 2, right? As I told you, it's nothing but the same, right? It's nothing but the same. Now coming to that part, like that much part is clear, right? And how do you calculate in the exponentiation function? Mod has been given to you. How do you calculate the exponentiation function? This particular function is nothing but the fast exponentiation, right? Fast exponentiation. If you a normal exponentiation function takes order of n time, right? But if you do fast exponentiation, so it will take order of log of n time or something like that. I am not exactly remembering, but it's something like this. Okay, so it will be logarithmic in time. So this is nothing but fast exponentiation, right? This is nothing but fast exponentiation. So as I told you, if I have already calculated some value, right, so I'll not calculate it, right? So that's what I'm saying. And if my power is odd, so in that case I'll multiply a single a. That is what I told you. This is nothing but a fast exponentiation. You can learn about it from Geeks for Geeks or anywhere else if you have a pre knowledge of this, so that's great. Also like the video if up till now things are clear, right? Now next up, like this is nothing but I'm dividing each time like b by 2, so b divided is equal to 2. That means the power each time is getting divided by 2, right? Because if I have calculated 8, if it was a to the power 8, then I have calculated a to the power 4 once, and I'll be using 2 times. I'll be using it twice so that I can reduce the number of computations, right? Give me a +1 in the chat. I can see a lot of people have joined us today. A +1 in the chat would help, right? Now next up, let's come to this function. In this function, what we'll actually be doing, if I'll initialize my answer to 1, and I'll run until my n and r are existing. Okay, n and r are greater than 0. So I'll calculate a is equal to nothing but n mod m and b is equal to r mod m, right? Like this. So what I'm doing is basically this is nothing but n factorial divided by r factorial n factorial divided by r factorial into n minus r factorial, right? So what I'm doing, basically I'm doing nothing but I have already stored all the values, right? As I told you, n mod m is already stored, right? So I'll just access it through the factorial array that I have already made, right? And then I'll also I'll multiply it with the inverse factorial of r, that is b is what? Inverse factorial of r, right? In I fact of b is not inverse factorial of r, and I fact of a minus b is what? Inverse factorial of n minus r, right? N minus r factorial, and taking the mod, so inverse factorial of that. And every time at every step I have to apply mod so that I do not exceed the value, right? I have to apply mod because that's something that's mandatory for me. Give me a +1 in the chat if things up till now are clear, right? A like to the video and a +1 in the chat would help us, right? In the end, after every time I'm computing, so I'm updating my answer, right? And I'm simply returning my answer in the end, right? Is this much part clear to everyone? Is this much part clear to everyone? And this is nothing but the normal way of calculating factorials. If you just had simple numbers also, so you'll be doing this, right? If the top value was lesser than the if the numerator was lesser than the denominator, in that case you will say that you have to return 0, things like that. So that's pretty much simple, right? This is what you are doing. You are calculating updating your answer for the final time, and in the end you are returning your answer, right? Is this problem clear to everyone? I hope that it is clear to everyone, right? Give me a +1 in the chat if this problem is clear to everyone, right? A +1 in the chat would help. A +1 in the chat. Okay? Right. So now coming back to this thing, as I told you, the thing about code era. So we have this channel that is code era. So on this particular channel, as you can see, a lot of educators are also teaching, like we are building a strong community where we are daily discussing about lead code daily challenges, things like that. We are making lead editorials for you can say a lot of contests that are happening, like we also made kickstart, things like that. I have code forces mastering sorting series, and I also have like you can see, like we have a lot of views on this channel, right? You can see this particular thing, like word pattern that I explained. It was this problem was asked in Uber, and it has 1.2k views, although the channel does not have much subscribers, right? So you can if you want, you can consider to search this channel, and if you like my explanation, my way of explaining, and like if you want to practice lead code daily, or if you want to be regular in coding, so you can follow this channel. On this channel we are regularly posting a lot of content. Like you can go through the playlist section. We have everything for someone who is wanting to learn DSA, someone who is wanting to learn anything else, like competitive programming or something, like you can see I have a series on mastering code forces, greedy problems, a lot of things like that, right? If I'll just show you this part, so it has a lot of views, right? 300 plus views, like, so you can consider to watch these things, and you can also like the video, also give me a +1 in the chat if things are clear. So this was the problem of the day for today. Tomorrow, for yesterday, today's problem of the day is I think related to strings. So you can consider to watch the problem of the day for today, solve the problem of the day for today. The problem of the day for today is reverse words in a given string. If you are able to solve this problem, right, this problem was asked in Adobe, Amazon, you name it and you have it, every company, right? So solve this problem and come back to this video, come back to solve this particular problem, that is problem of the day for today. Solve this particular problem and come back to this video after this video is over and comment down that I have solved this particular problem, and I'll be looking. If you also have any doubt with this particular problem, so you can come back to this video, comment down, and I'll be letting you know like where you might be stuck, right? So this was it from my side for today. But in the end, I will again say, like the video, subscribe the channel if you haven't, and give us a +1 in the chat, and take care. Till then, stay safe and happy coding.